What's up? Bill Witte back with more pre-algebra. Listen, at this point, a lot of people have told me, Mr. Witte, this stuff's pretty easy. Well, you know what? It is. Okay, the average grade on the tests that are taken at the assessment center for these remote classes, you know what it is? Somewhere between a 88 and an 89. It's not too shabby, okay? But you know what the average grade for this class is? An F. An F. You know why? Because people get behind. Somehow they don't watch a show or two, and they don't get to the homework. Of course, you can't do the tests until you've done the homework, okay? So be afraid. Be afraid. Make sure you watch the show every week or tape it. Stay up with us. Stay up with the homework, because that is the major problem, because the stuff is not that hard if you stay up and if you do the homework, okay? And if you have trouble staying up, remember that you can also go to the web page. Now, what was that address again? www.montgomerycollege.edu/pre-algebra. Okay, because you know I talk too fast sometimes, so you can always go there and replay the shows. Okay? Now let's see, what do we got today?
Oh, gnarly!
Oh, integers. You're going to like integers. They're pretty cool, and they're not hard, okay? But let's remember what we did last time first, okay?
Oh, right, guys.
And we covered exponents last time, okay? You remember that? Remember what exponents were? Well, exponents, while multiplication is multiple addition, exponents is multiple multiplication. You see, that 5 to the third power means not 5 plus 5 plus 5, but rather 5 multiplied that many times. You remember this, I hope. Of course, we can't do all three at once. We'd have to do the first two 5s, 5 times 5, get an answer, 25, and then take the answer and multiply it times 5, 25 times 5, and get your 125, ding-a-ling. So it's not so bad. Your brain cannot do more than one operation at a time. Okay, so you can only do two numbers. So you take the answer and then multiply the answer by the next number. Okay. Now let's look at a couple examples just so we're solid on this. For instance, 3 to the fourth power is, now this is multiple multiplication. 3 times 3, 4 times. Okay, let's see. See, 4 times. Well, but we can only do 2 at a time. 3 times 3 is 9. Take the answer, 9 times 3, 27. And take that answer, 27 times 3. You might need paper for that one. I didn't. 81, okay? But that's okay. Give me another example, Witte. Okay. 2 to the, fifth power. Well, we got to multiply 2 by itself, times itself 5 times. 2 times 2 is 4. Times 2 more is 8. Take the 8. Times 2 is 16. 16 times 2, 32. Not so bad, huh? This is just basic exponents.
Wait a minute.
What about 1 as an exponent? Remember that?
Now what am I gonna do?
Well, don't worry. You remember from last time. It's the same rule. There's no exceptions. Multiply it times itself. Bam! It's easy. 5. That's the answer. Okay? Don't make it hard. I told you this stuff is easy. Okay? Okay, at this point,
Pay attention, son. This is for your own good.
we know 5 operators if you think about it. Okay? Times, plus, divided by, minus, and exponent. Remember what operators are. Operators are the things that do the operations. And what's a terms? Terms are the things that get operated upon. The numbers, if you would, that get operated upon. Okay? Now the operations that we know at this point are plus, minus, times, divided by, and we just learned exponents. Okay? Okay, what is it about operations that we learned last time? The order of operations. I asked you to memorize them. You'll need to know them all the way through calculus. Do what's in parentheses first, then do exponents, then do any multiplication and divisions in the whole problem. You've got to finish them all off, and if there's more than one, you work left to right amongst them. Then you do all your additions and subtractions, and if there's more than one of those, then you work from left to right amongst them. And then the last thing we do is simplify any fractions that are in the problem. Okay? Well, let's look at some examples of the order of operations. Okay, now let's see. We have to do what's in parentheses first, but there aren't any parentheses in this case. Okay, so bag that. Then we have to do parentheses, then exponents. There aren't any exponents. Then we have to do multiplications. Well, there's a boatload of multiplications. The 12 times the 5, which is 60, and the 3 times the 6, which is 18. Notice I did the 60 first, then the 18. Okay, you work from left to right within the multiple multiplications. Okay? Now, after I did all my multiplications and divisions, I do my additions. There it is. Okay? And son of a gun. Okay? And you have to follow that order, or you'll get an answer. It just won't be the right one. Okay? Let's do another one.
Thank you, sir. May I have another?
Absolutely. Ooh. Well, let's see. We have to do what's in parentheses first. What's in parentheses? 8 minus 5. Okay, and that's 3. That's all I did in that step. Okay, don't try and do more than one thing in one step, or unless you're way smarter than me, you're going to get baffled. Okay, the next thing to do, parentheses, and of course you see the 3 in parentheses, but there's nothing to do there. Okay, the next thing is exponents. Well, there's 4 to the 2th. Okay, that's 16. Okay, the next thing to do, parentheses, exponents, is multiplication. There's only one multiplication here, and that's 6 times the 3. There it is. 6 times 3 is 18. Now we're going to do any additions and subtractions. If there's more than one, in which there is, we'll work from left to right. Well, left to right is top to bottom in this case. 2 plus 18 is 20, and 16 minus 6 is 10. Okay, now we've got a fraction, and we should reduce it, or actually do the division, 20 divided by 10, and get your 2.
I'm such a genius.
And you thought that one was hard. Okay? Okay. Now, when we deal with expressions, in letters and stuff like that, letters are going to follow the same rules as numbers, of course. Okay? So let's put some numbers in for these letters, and they're going to follow the same order of operations. Well, let's see. Instead of the A, we'll put a 4, and instead of the B, we'll put a 3. Now, I just picked those numbers out of the air just to demonstrate. Okay? So see where the A was, there's now a 4, and where the B was, there's now a 3. Now, the idea is we have to follow the order of operations. You got to know them now. What's in parentheses? That's the first thing. 2 times the 4. Okay, that was the first thing we did, is just what's in parentheses. We only had one set of parentheses. Okay? Now, the next thing to do is exponentiation. Note that we have 2 exponentiations. Okay, we have the 8 to the 2th, and we'll do that. We also have a 3 to the 2th. Okay? Note that we're not going to go 3 times 3 to the 2th. Okay? That 2 only has power over what he's right next to. Because remember what the order, why, you ask? Because the order of operations says do the exponent first before you do that multiplication of 3 times 3. Okay? So there's no question here. We definitely are, that 2 only has power over one of those 3's. Okay? So we're going to have a 64 there, and then we're going to square that 1 3 and get a 9. Okay? Just the one of them. Okay, now we do our multiplication. 3 times 9, 27. And the last thing we do is our subtractions, or additions and subtractions, and get a 37. Okay? Okay, so notice that letters follow the same rules as numbers, of course, because letters eventually become numbers. They're placeholders for numbers. Let's do one more. Okay? Let's see.
Do that again.
Okay. Now, instead of X and Y, I'm going to put
Heart failure.
7 and 3. Now, it's a little bit different in that there's 2 Y's. That's okay. Every place I see a Y, no matter how many there are, I'm going to put a 3. See what's happening here? Okay, so it's just more than one. That's all right, no big deal. Okay, now we'll follow the order of operations. Nothing to do in any of the parentheses. There are parentheses, but nothing to do. Exponents, let's see, 7 to the 2th and 3 to the 2th. Only the 3 to the 2th, not the 3 times 2. You do your exponents first, then the multiplication. Okay, let's see. I see where the 3's are going, and the 7. Okay, so there's your 7 squared is 49, and your 3 squared is 9. Okay, now I do my multiplication, which is just 2 times the 9, is 18. And now I have additions and subtractions to do. Which do I do first? Well, I said addition and subtractions, but when they're really of equal precedence, I'm going to work my way from left to right. I do the 49 minus 18 first, because there's a tie here kind of a thing. Get the 31, and then, and only then, I do the 31 plus 3. Okay? Thank you very much.
You never know what you're going to get.
Now the idea with this one, I want you to make sure you understand that those numbers that I put in, I just picked them out of the air. They could be different numbers. That's why we call these things variables. They can vary. Okay, what if, for instance, in this case, we instead let x be 5 and y be 2? See, wherever there's an x, I put a 5, and in both places I put a 2. I can put whatever I want. Okay, let's follow the order of operations. We're going to do our parentheses. We have none. Exponents, 5 to the 2th, 25, and just that single 2 to the 2th, 4. Okay, now we do our what? Parentheses, exponents, multiplication. There's 2 times 4. Get your 8. And now work left to right amongst the additions and subtractions. 25 minus 8, 17. Then, and only then, add 2. And we are there, baby. Okay? Okay, a couple other things we covered last time that I want to show you.
Wait a minute, 99. That gives me an idea.
For instance, a use of multiplication. Okay? Remember, a square, a use of, if you would, exponents, okay, is a rectangle that has sides that are equal. Okay? And area is how many squares are in that bad boy, right? Now, if this was, for instance, 3 feet by 3 feet, because it's a square, you could have counted how many squares. You could have gone length times width, okay? But since it's a square, you don't have to go length times width. You can go side times side, which really means the same thing since the sides are the same.
Cool.
Or you can say side squared. Side times side means side squared. Right away, a use for exponents here. 3 squared
Totally.
is 9 square feet. You could have counted. Now that you say, well, what good is that? What am I going to use that for? Well, if it's something much bigger than that and you don't feel like counting them, for instance, in this situation, and you only know one of the sides, you only know 7, but of course it's a square, so you know both. So the area of this, how many squares are there? Well, let's see. Side, 7, squared. 7 squared is 49. Without even counting, you knew there were 49 square inches. Okay? Another use of exponents, the area of a square. Okay? What else did we cover? Oh, translating phrases. Okay, we covered the fancy phrases for these things. Remember that?
Introducing.
The words that suggest addition. Remember what they were? Certainly the word sum
Yes.
means to add the two things, A plus B.
Survey.
8 more than something. Now, of course, you're starting with X and you're going 8 more than that.
Ooh, yes.
So there's another phrase that suggests addition. Okay, when we get to word problems, we're going to be hoping that you remember these words. The total of things suggests that you're going to add them. Whether there's 3 or 4 or whatever of them, you're going to add them up.
Survey says.
And something increased assumes that you're going to, of course, you have to add to increase it. So y increased by 3 would be
Ooh, yes.
y plus 3. Okay, now those are the words for addition. How about the words for maybe subtraction? The words for subtraction, A subtracted from B. Now this is a little bit difficult. Which did you start with? Now the words say A subtracted from B. So you started with B and you subtracted A from it. So this one's a little bit screwy in that it's going to end up B minus A, even though you started saying it with A subtracted from B. You see what's going on there? You're taking B and subtracting A from it. 8 less than X. 8 less, not 8 less X, 8 less than X. You're starting with what? That's what I always ask myself. I'm starting with X, so you know what to write first now. x minus 8. 8 less than x. Yeah, it's not that easy, huh? Now here's a word you have to remember, the difference of y and c. Anytime you use the word difference, okay, the difference between two prices, the difference between two people's heights, etc., you're always going to subtract. So the difference between y and c is y minus c. Get to know the word difference suggests subtraction. The word decreased, something decreased by something. So z decreased by 3 is going to be z minus 3. So there's your addition and subtraction words. Logically, the other ones we went over were multiplication, right?
Introducing.
Words that suggest multiplication. The word product infers the answer of a multiplication problem. So the product of A and B really means A times B, okay? The word of, we're going to find out in many future problems, also suggests multiplication. 8x's or 8 of x means 8x or 8 times x. Twice x, of course, means a special kind of multiplication with 2. 2 times that, or 2x, 2z, I'm sorry. And y times 3, or times, usually that's going to infer a multiplication as well. Okay, so let's see, what do we have left to do? Division, huh? Words that suggest division.
Now what am I gonna do?
The word fancy schmancy, the word quotient. Like product was the answer to a multiplication problem, quotient is the answer to a division problem. So the quotient of A and B is A divided by B. Okay, looks fancy, but it isn't. Okay.
I can do that, but I don't want to.
8 into x. Now you're starting with what and taking something into it. You're starting with x and taking 8 into it. So this one's going to turn around to x divided by 8. Okay, you could have written a division as well. I'm just showing you a different notation. This one's obvious. Y divided by 3. Okay. And what else do we have? That's it. So it's time for today's new stuff. And remember what we promised we're going to cover today? Integers. Okay? Integers. What the heck are integers? Before we even cover, we're doing stuff with them. Let's see. There's basic vocabulary we're going to know about, or you should already know about number systems, and that is the natural numbers. What are the natural numbers? Well, when the first caveman started counting something, he counted his rocks or counted his whatever, or counted his girlfriends, okay? What did he start with? He started with 1. It was natural, wasn't it? So the natural numbers, 1, 2, 3, on up, start with 1, okay? And you think, well, geez, that's all I'd ever need. Well, then what about the ugly caveman? What about the ugly? He didn't have any girlfriends, okay? So he had to consider, whoa, there's another number here. How about 0? Yeah. So when you want to talk about 0, the set we're going to use is called the whole numbers, okay? When we don't want to talk about zeros, like in division and other times, when I don't like 0, okay, we'll use the natural numbers, okay? So these are the sets you're supposed to already know. Now I got a new set for you today, okay? This same caveman started borrowing stuff and he started owing. Well, now we got to start talking about negatives. Neither the naturals nor the wholes consider negatives. So that's when we start talking about our old buddy integers. Okay, now integers, if you look, the integers are the negative numbers, -1, -2, -3, -4, etc., down to infinity, 0, and, the positive numbers. Okay? Got the idea? So that's what we're going to start using. Not just the negatives, but it's everything. Okay? So the integers, we'll say, are the signed numbers. The positive ones, the negative ones, and what did I forget? 0. Okay? There's nothing in between, none of the fractional ones when we talk about integers. Okay? Just the positives, the negatives, and 0. Okay? And note that as we go far, it seems hopefully obvious to you, but the farther right we go, the larger a number gets on the number line or anywhere. Okay, and the farther left we go, because you got to be able to visualize this, the smaller a number is going to get, of course. Okay, but when you're looking at it, but you may not have that number line right in front of your face. Okay, so think about it, kind of, envision it when we do some operations.
Wait a minute.
We have positive. Why do we want positives and negatives anyway? Okay, well, you can think of many cases in real life when you'll need it. Okay. Obviously, we talk above sea level, we're talking about positive, okay? But we know that there can also be below sea level. So we'll need what for that? Negative numbers, okay? What else? Of course, when it gets hot, we're talking about above freezing, so we're talking about positive numbers. But what's the alternative to that, which we felt before?
Take this man to the cooler.
That's when it's cold, and that's going to be below freezing. We'll need negative numbers.
Excellent.
If you made money, you're going to be in the positive, okay? In the black, of course, we call it, okay? But some of us know, work in the stock market,
Yes, you're in deep doo now.
you could have lost money. So we have to have a number that represents that, and that would be a negative number, of course, okay? All these things can happen. These are just some examples of the use of these, okay? Okay. When we start talking about the integers, I want to at least make sure that you understand the idea of inequality signs. Inequality, what does that mean? When they're not equal. Okay, when two things are not equal, one of them is bigger. That's for sure. Okay, so what are the signs we're going to use for that? Well, the greater than sign, okay, looks like this. And the less than sign looks like this. Okay? Now, that seems easy, but it's not. I'm going to throw some curves at you here. This would be read 5 is greater than 3. Okay? But I want you to note, it could also be read, if I was really interested in the 3, if 5 is bigger than 3, what is 3's relationship to 5? That could also be read, 3 is smaller than 5. Okay? Consider that. This one could be read, 2 is less than 6, because that is the less than sign. But if I asked you to say the 6 first, of course, if 2 is less than it, what is 6's relationship to 2? You would say 6 is greater than 2. Okay? Consider that, because you're going to have to be able to switch things around when we get to variables, etc. Okay? I'll give you an easy way to remember that.
Wait a minute, 99. That gives me an idea.
Well, take a look. Rather than memorizing these things, usually people pick one way. You can either remember that the arrow of the sign, if you would, always points to the smaller. See how 3 is smaller than 5, so the arrow's pointing to it. Okay, some people like to remember that, but you know what? That's not the one I like to remember. I like to remember the alligator. The sign looks like an alligator, doesn't it? Always wants to eat the larger number. He wants more to eat, okay? So the mouth always opens to the larger thing. That's the way I remember it, okay? Let's try some problems with this, for instance, okay? 7 and 10. Which sign would you put? Remember, the mouth always opens to the bigger thing. Well, let's see. There you go. The alligator wants to eat that 10 as opposed to the 7. Now, which way would the mouth open this time? Of course, 8 is bigger than 3, so we'd put the sign in that way, okay? Remember, the alligator wants to eat the bigger thing. You say, how? This is easy, right? Well, wait a minute. Who's bigger this time? Well, you need to imagine the number line. Okay, remember what it means to be bigger. Whoever's the farthest to the right on the number line. Well, let's see who's the farthest to the right. That -3 is farther to the right than the -5. So he's actually bigger. So the mouth would open to him. You get the idea how you have to imagine that number line. Okay? The mouth opens to the bigger thing. Now, what about 0? Well, 0 is a number. It works the same way. Who is the furthest to the right on the number line? Well, 0, let's see, there's 0 and there's -3. 0 is bigger than -3. Okay, so if you get confused, remember, imagine that number line, and the mouth opens to the bigger thing. Okay, I think that's an important thing to remember. Okay. What about this one? A negative and a positive. Well, obviously, I shouldn't say obviously, the positive is going to be bigger than the negative because the positive on the number line is farther to the right. All the positives are farther to the right than any of the negatives. Okay. So the mouth will open to the bigger thing, the 3 in that case. Yeah, I guess you got the idea now, huh? I need to talk about, when we talk about integers, we're going to talk about distance. Probably an obvious thing to you. If you drove 7 miles to school today, you drove 7 to get here, how far did you drive to drive home? Did you drive negative 7 miles? No. Distance can never be negative. Even if you drove backwards, you still drove 7 miles, right? No matter which direction you go, distance can never be negative, okay? Now you might be thinking, what does this have to do with today's subject, integers? Okay? Well, when we work with integers and we work with distance, you're going to hear a term, fancy term, called absolute value, the absolute value. Okay? What is the absolute value of a number? The absolute value of a number is the number's distance from 0. You got to be able to imagine the number line. And remember, distance can never be negative. The number's distance from 0. So for instance, the absolute value of 3, now sometimes this is so easy it's hard. The absolute value of 3 is its distance from 0. Well, let's see. Its distance is 3. So the absolute value can never be negative. The absolute value of 3 is 3. Okay, this is almost too easy. What are you doing? What about the absolute value of negative 4? Well, remember what it is. It's the distance that negative 4 is from 0. Now, distance can never be negative, so it's 4. So it's just always the positive value, right? Distance can never be negative. So the absolute value is basically the positive value. Now, the higher number doesn't matter. The absolute value of negative 23 it's way out there. You can still imagine it, though, right? What's the distance going to be, since it can never be negative, is 23. The absolute value of negative 23 is 23. So that's a pretty easy concept. Since you know its distance, it can never be negative. But you know what people always screw this up with? Well, they screw it up with the opposite of a number, okay?
Wait a minute.
The opposite of a number, we use a different word, so it means something different, okay? The opposite number of a number is the number on the other side of 0 in the same distance, okay? For instance, the opposite of 3, of course, the absolute value of 3 was going to be 3, right? The opposite of 3 is, let's go the other way, is negative 3. Okay, that's not the absolute value. It means something different. Opposite and absolute value means something different. Okay, what about the opposite of, let's see, the opposite of negative 4? Okay, now this is where you thought you knew it. You don't know nothing. The opposite of negative 4, there's negative 4. We go the other direction, is 4. Now in this case, the absolute value is the same as the opposite. Okay, but it's just a coincidence, just a smagincidence, okay? So the opposite of negative 23, let's go the other direction, is positive 23. It's just in the other direction, okay? So you don't confuse absolute value, where it's always positive, with opposite, where you just always switch it, okay? The opposite is the same distance from 0, but in the other direction, okay? Okay. If there is a hard part today, I don't think it is. Don't make this hard. If there is a hard part, it's adding integers. Okay? And you're going to need to do this, adding numbers that are negative and positive throughout all of this semester, next semester, and the semester after that. So make sure that you understand this. Don't just memorize it. Understand what we're doing. Okay? Well, adding integers is like
Of course you realize this means
a battle by two teams, okay? Consider that integers that have the same sign are on the same side. Okay, we got let's choose up sides here first. 0 is the referee, okay? So we're going to add, because 0 doesn't affect anything when you add to it, right? Well, you got the negative team, and you got the positive team, okay? Everybody on the negative team is negative, and everybody on the positive team, no matter who you are, you know, if you're positive, you're on the positive team, and if you're negative, you're on the negative team. Okay, all the negatives go over here, and all the positives go over here. So it's just different teams, okay? Just break them out. I'll put all the negatives one place and all the positives in another, okay?
Totally.
Well, ooh-la-dee-da.
This is simple. You can tell negatives from positives, right? Okay, now we're going to add them, okay? What are the possible screw-ups we can do here? Well, let's take a look. Integers that are on the same team
Yes.
just add to each other's strengths. This is easy. I got the two teams. So two negatives, -7 and -2, they make each other even more negative. I got -9. This is simple, right? Why wouldn't it be more negative? It adds to each other's strengths. +7 and +2, well, you already knew that, make a +9, of course. -3, -5, they're both negative, so your answer is going to be even more negative. -8. Okay, they're on the same team, so they work together. 3 and 5 are on the same team. They're on the positive team. So they make even more positive. They make 8. You knew what number it was. You just didn't know whether it was, you know, positive or negative. -12 and -4 are going to make even more negative. -16. And, of course, positive and positive, 12 and +4, make 16. Okay? So that you think you know everything at this point. The hard part is when the integers have different signs. Okay? Remember we started off, this was the idea of a battle. Okay? Well, that means they're on opposing teams. You might have one positive and one negative. We got a battle going on here. Okay, so what's going to happen when you have one of each?
Of course you realize this means war.
We're going to have a battle. The way to do this is we'll begin the battle. Okay, we'll take one against the other. We'll clear away the casualties, because there will be casualties. Okay? And then we'll display whatever's left, whoever's left standing, if you would. Okay, that's our idea when we're going to add things that have different signs. Okay? We got to do a couple of these because this is the hard part. Okay? Let's do a battle. Okay, we have -5 versus 3. Okay? Now it's important to note before we even begin this, okay, that while the two teams, one is bigger than the other, if you would, each individual member of these teams is of the exact same size. -5 has 5 negative members. Okay? -1, -1, -1, -1, and -1. They're all, you know, ones, if you would. 3 has 3 members. Okay? Now, each individual is the same size. Okay? So that when one negative meets one positive, you know what's going to happen? Death. Casualty, if you would. Let me demonstrate. Bring out the -5s. Begin the battle. Okay, there's the 5 negatives. Now remember, each negative is of the same size as a positive. Okay, now it's time for the positives. That's all we have. Okay, I think you have an idea who's going to win this one. But let's do the battle. These two take on each other. What's going to happen? They're gone. These two take on each other. They're gone. Anybody left? Oh, we still have one left on the pod. He's hanging on there. Doesn't matter which ones you pair up. These ones are gone. Okay, so now we've cleared away the casualties. You know when casualties happen, when a -1 meets a +1. And it's time to display the result. And what is the result here? Who's left standing? 2 negatives. And that's the deal. The answer is -2. Okay, so that whenever we are adding a positive and a negative, we're going to battle. Let's do another one.
Yes!
Do that again.
Here we go. Today we
I
have
have been chosen.
negative
Farewell,
2.
my friend. I go on to a better place.
I think you do. Is going to verse 6. Who do you think is going to win? Well, always the bigger guy wins. But let's bring it out. Bring out 2 negatives, and oh. There's your 6 positives. Oh, it's going to have a kicking chicken here. Okay, let's see. Let's clear away the casualties. How do casualties occur? 1 negative versus 1 positive. These 2 guys, what's going to happen? They're gone. These 2 guys got together and ouch. And I think that's it for negative 2. So what's going to happen here? Display the result. Who's left standing? 4 positives. So the answer is positive 4. That's not so bad.
Despicable.
Well, you win. A bigger guy wins. Okay? Now you can see that, but you're going to have to be able to imagine what's happening with perhaps larger numbers. Let's do a real big one. The big one.
Brace yourself for immediate disintegration.
Okay, negative 25 is going to verse.
You better say your prayers, you flea-bitten varmint.
Gonna verse 30.
Blow you to smithereens.
Let's see. Bring out the negative 25s. Oh, bring out the 30. Well, they came out fast. Bring out the 30. Okay, now we're not going to do each one at a time. We're just going to clear away the casualties.
Ba-ba-boom.
Oh, that was quick. Quick and clean. Now, who's left? And I want you to notice what happened here, because you're going to have to be able to do this in your head. What happened is there's only 5 left, 5 positives. So the answer to this problem is positive 5. You get the idea kind of what's going on with these battles. Okay, if they're on the same side, they add to each other. If they're on different sides, there are casualties. Well, let's practice some more.
Yes!
Let's see if you know what's going to go on. Let's do a couple. Basically, what we're going to do with these, if you wanted to have a rule, negative 5 plus 3, the reason it's negative 2 is because we're going to take, and that's why I taught you, the absolute value of each of them and subtract. Okay, you see why we subtracted? Because you saw the war went on, and whoever won was the bigger guy, and he won by a subtraction of the 2 absolute values. So in this case, basically what we would have done, I know you did it in your head, is that we subtracted 5 minus 3 and got 2, and then we're going to use the sign of the larger number. Who was the larger number in this problem? The negative 5. So
You are correct, sir.
the answer, of course, as we saw, was negative 2. In this case, why is the answer 4? Well, we have a battle between 6 and negative 2. We subtract the absolute values, 6 minus 2, and get 4. And who's the larger, the 6 or the minus 2? Well, the 6 is a larger, I should say, who has a larger absolute value? The 6. Okay? So he wins. You knew he was going to win. So the answer is positive 4. Okay, that's why it's positive 4 and not negative 4. Okay, and then we went to the other ones. The same rule held. We had negative 25 and 30. We subtracted the absolute values of the 2 numbers. The absolute value of 30 is 30. The absolute value of negative 25 is 25. We subtracted and we got 5. Okay, and we knew it was either 5 or negative 5. We're going to use the sign of the larger, and in this case the larger was 30.
You are correct, sir.
So the answer is positive 5.
Hasta la vista, baby.
Remember, always when you're adding signs, a positive to a negative, a mixture, who's going to win? The big guy. Okay? Good show. We're going to go on now. If you can do addition, you can do subtraction. Yes, we can. Let's try it. Okay? Subtracting integers, one a little bit extra. Okay, let's take a look.
Perhaps I could be of some assistance.
Well, remember, if you know how to add, I'll bet you it's going to help you a lot in subtracting. Remember, to add, integers on the same team, they add to each other's strengths. Okay? So negatives make more negatives, and positives make more positives. Remember, negatives make more negatives, And positives make more positives. Okay, that's when they're on the same team, negative to negative, positive to positive. When they have different signs, what was the rule that we used? We subtracted the absolute values of each and used the sign of the larger. So we went the absolute value, 5 minus 3, got 2, and used the sign of the larger, which is negative, and our answer was negative 2. Remember that? Let's do one more. We subtract the absolute values. The absolute value of negative 2 is 2. The absolute value of 6 is 6. So 6 minus 2, get our 4. And we're going to use the sign of the larger, which in this case is 6. We use a positive 4. Okay, that's the rule of addition. Subtract the absolute values and use the sign of the larger. We have to know this rule.
Correct, sir. That's the fact, Jack.
Now what am I gonna do?
If you're confused with subtracting, we're going to change it to an addition problem. Now on this one, I'm not confused. Not a problem. 8 minus 3 is 5. So I'm not going to go through that rule. Still not confused. 8 minus 3, not a problem. This one,
I can do that, but I don't want to.
I'm confused. 8 minus negative 3. Here's where I got a trick for you, okay?
Just remember that this thing isn't as black as it appears.
Hey, it's not going to be that bad. If you get confused while subtracting, don't.
No.
Don't subtract. If you get confused while to subtract, if you're not confused, go ahead and do it. But if you are confused, don't do it. Refuse to subtract. Okay? How can you do that? An alternative to subtracting, of course you're only going to use this when you're confused, is to add its opposite. 8 minus negative 3. Instead of doing this subtraction, let's add the opposite. What's the opposite of negative 3? Now, it's easy. And you know, why can we do this? Because remember, when you make two changes, I got a picture here of a light switch. If you started with a light switch on and you switched it twice, where did you end up? Right back in the same place. And that's what we did. We switched our subtraction to addition and our second number to its opposite. So we made two changes. We end up right back where we were, except it's easier. Okay, so whenever you get confused, change the subtraction to an addition and change the second number to its opposite.
Do that again.
Okay, we'll do another one. Negative 5 minus positive 13. Here's one where I would be confused. So let's add its opposite. Change, what's the opposite of 13? There she blows. Negative 5 and negative 13.
Excuse me, Professor Brainiac.
You already knew that because they're on the same team, right? So negative 5 and negative 13, they just get together on the same team.
Yeah, baby.
And got a negative 18. So you took a hard problem and changed it into an easy one.
Thank you, sir. May I have another?
I know. We'll do another one.
Yes.
Add the opposite if you get confused with subtraction. Negative 8 minus a negative 3. Got enough negatives there? Oof. Add the opposite. What's the opposite of negative 3? Positive 3. Oh, this is easy now. Now, wait a minute. We've got a battle going on. We've got negative 8 and positive 3. Remember how to do addition? You're supposed to be an additions expert. Negative 8 and positive 3, we subtract the absolute values, 8 minus 3, and then use the sign of the larger, which was negative 8. So it's a negative 5. So we've changed a somewhat difficult subtraction problem into an addition problem, and I think that's your best strategy.
Who cares?
Well, what are we going to use subtraction for? Remember the word difference infers subtraction.
Allow me to demonstrate.
Let's try a problem here. If this fella Bill got a plus 3 on his last hole at Augusta, Tiger got a minus 2. Okay, that's me and Tiger. We play all the time. Okay, what is the difference in our scores? Difference infers subtraction. Now you know Tiger kicked my chicken. You know that, okay? How much did he beat me by is the idea, the difference. Difference infers subtraction. So we're going to go my score minus his score. Okay, now the minus is for the word difference, and the -2 is for his score. Okay, now how are we going to do subtraction? I'm a little bit confused here. I'm going to change the sign of this. I'm going to add, change the subtraction to add, and change the sign of the second number. Okay?
Cool.
Holy goalie, it's not cool. He beat me by 5 strokes on 1 hole. Okay, but you can see the use of this.
Do that again.
Okay, well, let's consider the average temperature in Peru is a hot 92 degrees. The average temperature at the North Pole is -52. Okay, there's going to be a big difference. What's the difference between these two numbers? And you know what difference means? It means to subtract. So we're going to go 92 minus a -52. Minus for the difference, and of course -52 was the number we were working with. Now this might confuse you, okay? Whenever I'm confused on subtraction, I'm going to use my rule. Add the opposite. So I change that subtraction to an add, and change -52 to its opposite, +52. Now it's a pretty easy problem to do. And the difference is a huge 144 degrees between Peru and the North Pole. Okay, let's review. Okay, the integers are, you may remember, the positive numbers, the negative numbers, and of course 0. Things that are farther to the right are larger. Of course, things that are farther to the left are smaller. That's our definition. Okay? Inequality signs, the greater than and the less than sign. This could be read 5 is greater than 3, but it could also be read 3 is less than 5. Okay? So don't lock yourself into, the direction of this thing. This could be read 2 is less than 6, because that is the less than sign. But I want you to be able to switch things and read it backwards. 6 is greater than 2. So how did we remember that?
Wait a minute, 99. That gives me an idea.
Well, rather than memorizing, you either remembered that the arrow points to the smaller one, or I would stress that the alligator eats the larger number. The mouth opens to the bigger thing. Okay? Remember absolute value. Okay, what was absolute value? Absolute value was the distance a number is from 0 on the number line. And remember, distance can never be negative. For instance, the absolute value of 3 was almost too easy. Was the distance it is from 0, can't be negative, was 3. Okay? The absolute value of -4, which was the distance -4 is from 0, of course distance can never be negative, was 4. Okay? The absolute value, now here's where you're going to have to use your imagination. The absolute value of -23 is the distance that -23 is from 0 is 23. So you see how you kind of, well, I think you don't have to use your imagination. Just remember that absolute value is always positive. Okay? This is different from
Wait a minute.
the opposite of a number. Okay? We have to know what these words mean. The opposite is the number that's the same distance from 0, but on the other side. Okay? So it's a totally different meaning. The opposite of 3, go the other way, is -3. The opposite of -4, go the other way, is +4. Now that's confusing because in this case, just remember, the opposite was the same as the absolute value. So that can happen, okay? You just got to know your definitions. Of course, the opposite of -23, you'd have to use your imagination, is +23 in the other direction, okay? Remember what the opposite is. Remember adding integers, and we always break them into teams. Okay, the negative team and the positive team, okay? And if they're on the same team, They add to each other's strengths. Negative 7 and negative 2 make more negative. Positive 7 and positive 2 make more positive. Okay? If they're on the same team, they add to each other's strengths. Negative 3 and negative 5, even more negative, negative 8. Positive 3 and positive 5 add to each other's strengths, positive 8. Negative 12 and negative 4, even more negative. Positive 12 and positive 4, even more positive. Okay, so they add to each other's strengths. When they're on the same team, when they have the same sign, you simply add them and use that sign. Remember, the screwiness was when they had different signs, and that's when we had our little battle. And there was a rumble.
Of course you realize this means war.
When there's a battle, there's casualties, unfortunately. So to do integers with different signs, we began the battle, we cleared away the casualties, and then we displayed whoever was standing. Remember, for instance, when minus 5, remember the great battle when minus 5 took on 3. Now, I know who the odds are on here because I know who's bigger, but let's watch what happens. Let's begin the battle. We need to bring everybody out. Bring out those minus 5s. Okay, 3, come on out. Okay, that's our first step. Now clear away the casualties. Every time a negative 1 meets a positive 1, what happens? Casualty. Okay, anybody left? Oh, well, we're not going to leave you standing. Okay, once all the casualties are cleared, all the battle has been fought, we display the result. And what really happened, of course in this case the answer is negative 2.
Yes!
What really happened there was we took the absolute value of both of those numbers, subtracted, and used the sign of the larger. For instance, the negative 5 and the 3, we took the absolute value of negative 5 and the absolute value of 3, 5 and 3, subtracted, got 2, and used the sign of the larger.
You are correct, sir.
To do the negative 2 and the 6, you may remember, we took the absolute value of both of them. Absolute value of 6 is 6, the absolute value of negative 2 is 2, subtracted, and then used the sign of the larger. In this case, 6. So the answer was 4. Here again, remember we use the absolute values of each, subtracted, and use the sign of the larger.
You are correct, sir.
Okay, so there's the different rules for addition. Remember the rules for subtraction.
I hate you.
Just remember that this thing isn't as black as it appeared.
It wasn't that hard. When we got confused with subtraction, we refused to subtract.
No.
We just didn't do it. Rather than subtract, if you're confused, the alternative was to add the opposite. For instance, this was confusing to me. So rather than going 8 minus negative 3, I changed this problem to an addition of the opposite. And see why you needed to know the opposite of negative 3? The opposite of negative 3 is positive 3. And now it's an easy problem. Remember that 2 switches get you right back to where you were. So 8 plus 3 is easy. Okay, that's only when you get confused.
Do that again.
Okay, let's do one more.
Oh.
Oof. Negative 5 minus positive 13. Add, change it to an addition problem, the opposite. The opposite of 13 is negative 13. Now this isn't that bad a problem because I've got 2 people on the same team.
Excuse me, Professor Brainiac.
That's the rule for addition. Negative 5 and negative 13, 2 people on the same team just make more negative, and we get?
Yeah, baby, yeah!
So it's not that bad. You can change a problem that's a little bit difficult into something that is not hard at all.
Thank you, sir. May I have another?
Okay, one more. Let's see, negative 8 minus negative 3. Change an addition problem into adding a subtraction problem into adding its opposite. Now it's an addition problem of two things that are on different teams. This is probably the hardest problem that we did. So now it turns back into what? A subtraction problem, right? When I have to add things that are on different teams, I subtract their absolute values. The absolute value of -8 is 8. The absolute value of 3 is 3. 8 minus 3. And use the sign of the larger, the negative, and I get a -5. So you really have to know your addition.
Do that again.
Okay? How about a word problem with this? Remember the average temperature of Peru was 92 degrees? And the average temperature of the North Pole was -52, and we needed to know the difference between those two, which is a lot. Okay? Difference infers subtraction. Remember the word difference, okay? So we're going to take our 92 and we're going to subtract, you see the black subtract sign, we're going to subtract -52. You see two of them because the subtraction sign is for the difference. The negative is because it's -52, it's because it's cold, okay? So how do we do this? We change our subtraction to an addition problem, because I was confused here. We add the opposite. What's the opposite of -52? +52. And the reason I did that is because now it's not that bad of a problem. 92 and 52, I'm thinking we can add, and we get 144. And the difference is, in fact, 144. Okay, now it's your turn to do the homework. Okay? Now, I hope you remember, you're going to learn more doing the homework than listening to me babble on TV, okay? So if you have any trouble with the homework, of course, you don't just look at it, you do it, okay? And if you have any trouble, or if you're stuck, don't forget that you can go to www.montgomerycollege.edu/pre-algebra and replay the show, or you can email me at bwitte@mc.cc.md.us. So until next time, do your homework. Thank you. Thank you for listening. Thank you very much.